Hello and welcome to yet another video of Cornerstones of Math. Today I've got you this interesting problem. The quest here is to find the function f of t defined on the interval from negative pi over 2 to positive pi over 2 that satisfies the relation integral of f of t from 0 to inverse tangent of x gives the result inverse hyperbolic sine of x for all real numbers x. Before we actually dive into the problem, a quick side note about the domain of our function f of t. You can easily notice that inverse tangent of x is in between negative pi over 2 and positive pi over 2 for all real numbers x. So the given interval of integration cannot exceed the interval from negative pi over 2 to positive pi over 2. That is why the domain of f of t is restricted to this interval. We can obtain the information about f of t only for this interval. Now let us actually solve the problem. We need the notation for the antiderivative. So let integral of small f of t be capital F of t plus c. That is, capital F of t is one of the antiderivatives of small f of t. Then, by the fundamental theorem of calculus, this relation can be written as capital F of inverse tangent of x minus capital F of 0 equals inverse hyperbolic sine of x. We differentiate both sides with respect to x, which gives, by the chain rule, first we have small f of inverse tangent of x multiplied by the derivative of inverse tangent of x. And this term is a constant, so this term just gives 0. So this must be equal to the derivative of inverse hyperbolic sine of x. To find the derivative of inverse tangent of x, which we will call y, let us write this as tangent y equals x and differentiate with respect to x. Then the derivative of tangent is secant squared, so secant squared y multiplied by dy over dx by chain rule. And on the right hand side, the derivative of x with respect to x is just 1. Therefore, dy over dx equals 1 over secant squared y, and secant squared y is equal to 1 plus tangent squared y. And tangent y equals x, so we have 1 over 1 plus x squared. Let's use the same method to find the derivative of inverse hyperbolic sine of x. So first we write y equals inverse hyperbolic sine of x. Then we have hyperbolic sine y equals x. And we differentiate with respect to x, which gives hyperbolic cosine y dy over dx equals 1. Therefore, dy over dx equals 1 over hyperbolic cosine y. And using the famous square identity of hyperbolic functions and the fact that hyperbolic cosine is a non-negative function, this equals 1 over positive square root of 1 plus hyperbolic sine squared y, hence it is 1 over square root of 1 plus x squared. As for the derivative of inverse hyperbolic sine of x, there is another method, which is to use the alternative expression of inverse hyperbolic sine function. From x equals hyperbolic sine of y, this means that x equals e to the power of y minus e to the power of minus y over 2, which gives e to the power of y minus 2x minus e to the power of minus y equals 0. So multiplying e to the power of y, we have e to the power of 2y minus 2x e to the power of y minus 1 equals 0, which is a quadratic equation of e to the power of y. And by the quadratic formula, you can easily obtain that e to the power of y equals x plus square root of x squared plus 1. We used positive sign here because e to the power of y must be positive. Therefore, y, which is the inverse hyperbolic sine function, can be written as ln x plus square root of x squared plus 1. And if we differentiate this, we obtain first the derivative of ln, so 1 over x plus square root of x squared plus 1. Then by the chain rule, the derivative of the inner part, so 1 plus the derivative of square root, so 1 over 2 square root of x squared plus 1, multiplied by the derivative of x squared plus 1, which is 2x. And if we simplify this, we obtain 1 over square root of x squared plus 1, which is the same derivative as the previous method. Therefore, back to this relation, the result of differentiation is f of inverse tangent of x times 1 over 1 plus x squared equals 1 over square root of 1 plus x squared. So f of inverse tangent of x equals square root of 1 plus x squared. We want to find f of t, so let inverse tangent of x as t. Then naturally t is greater than negative pi over 2 and less than pi over 2, and x is equal to tangent t. Therefore, we have f of t equals square root of 1 plus tangent square t, and 1 plus tangent square is secant square t, and in this interval, secant t is positive, so we simply have secant t, defined on this domain. This means that integral of secant function from 0 to inverse tangent of x gives inverse hyperbolic sine function, which is the same as this one, which is a beautiful result, I think, seeing all those different types of functions nicely related. And that's all for today's video. Thank you all for watching. Please don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.